Welcome to question 87 and 88. Let's do it. If you got this one wrong, let's dive in. A lot of people have trouble deciding between the two tests. They kind of psych themselves out. On the real thing, if you actually do it in the calculator, you know you have the wrong test if the information given doesn't match the information you're trying to put in here. It's like the calculator's asking for one bit of info, but the problem's giving a different, and you feel like something's wrong, and you're right. Your gut's telling you something's wrong. But in a general question like that, it's a little bit harder to piece through. So looking at this question, it says, we were working at a factory and we have 200 employees and we have two different techniques. And so we split them in two groups, and one group of 100 does one technique, one group of 100 does another. Immediately, I'm looking around for whether or not they gave me the standard deviation of the population. Because they didn't, I can't do a Z. So that's out. Can't do Z. A is out. Chi-squared, I didn't see any goodness effect. That's weird. That doesn't sound right. One sample t-test, paired t-test, two sample t-test. So it's definitely a t-test. We don't know which one. So looking at that, how do I tell the difference? Let's talk about that a little bit. Again, this looks like a mean question, and you can't find the standard deviation of the population. You have to be given that. And if you are not given that, you're doing a t-test. Also, if I did have to set up an H sub O, it looks like the mu of group number 1 is 100 people, and I would calculate that. And then the mu of the second group, and that's another 100 people. A paired test is if we compared the same 100 people before and after. So that's paired. That's not what's happening here. So it's not a paired, and it looks like two totally separate samples. So my H sub O would be mu1 is equal to mu2, or mu1 minus mu2 equals 0, meaning there is no difference between the two techniques. Anytime I find a difference between two techniques, or two pills, two pieces of medication, two exercise programs, those are two samples. And that's a two-sample t-test. If you put this in the calculator, you'd notice you have two outcomes in each of the studies. So that's definitely two samples. Let's look at the next question. '88. Let's take a look. It says, we did a random sample, and we're trying to decide which one or what the difference is between a 90% confidence interval and a 95% confidence interval. So I took the following notes. I said to myself, okay, let me look on my formula sheet. So on my formula sheet for confidence interval, it says the stat plus or minus the critical value times the standard deviation of the statistics. So I can do a 90-degree confidence interval or a 95-degree confidence interval, just depending on what I decide to do. So what's the difference between the two? Well, the difference is the critical value I choose. So if I am doing a proportion question, the critical value for a 95% confidence interval is almost 2, and a 90% is not almost 2. So notice I'm going to be adding and subtracting 2, or adding and subtracting 1.6. So if I think of that from an interval standpoint, let's say my number is 5. Well, 5 plus or minus 2. Or 5 plus or minus 1.6. That's narrower. And in class, anytime I say, okay, a 90% confidence interval, now a 95% confidence interval, the 95, I'm casting a bigger net because I'm trying to capture the true mean. A wider confidence interval is the higher percent confidence. So that's why the answer is definitely a 90% confidence interval will not be as wide as a 95% confidence interval. Thank you for joining us.